Hey guys, you may be wondering, why am I wearing a mask? Why am I on the floor? Those are all very good questions, but those are questions that are not going to get answered today. Instead, you know what questions will be answered? How do we figure out species are related to each other? You know how like we say we're related to monkeys and all that? How does science do it? Well, today you're going to learn. It's called cladogram. So enjoy the video and like always, like, comment, subscribe. Hey guys, alright, so today we're going to learn how to use and set up a cladogram. What a cladogram is basically is like it's an illustration like right here. It's there to help us figure out the relatively closeness of two species, like how far long ago did they divert into their own separate species. So it's like how closely related they are. So, for example, if we have 4 different species that live together, let's call these single-cell organisms, a cladogram is going to help us figure out how relatively close they are. So, you need information first for a cladogram, and this is another tool that helps us figure out how far away not only are they from each other, but like what common ancestor all these species share with each other. So the first thing I would personally do to start this off is we need to look at all of the species that we have, and we have to look for a homologous structure that they all have. And right now that would be a big circle. So we could say that these are single cell organisms and that the circle is just a cell membrane, and then they all share a common ancestor. So if we know that right now that out of all of them we have the 4 all share that big black circle, that's going to be the first one they have. All right, so we know that will go there then, so we have to figure out the rest, the other order. So now we only have 3 to pick from. So from the 3, what homologous structure do they all share? Oh my god, that is 100% right. That one kid who I know said that. It's actually the green eyes. All right, let's say it's a green nucleus. So just say, yeah, there we go. Let's say it's a nucleus. So now at this point, let's just say maybe right here, they developed a nucleus. So unfortunately, this species doesn't get the green nucleus because that's where it diverted off of, like, if you want to call it like an evolutionary line, or like this is how like they adapted to different species. Sure, that's fine. Maybe a little incorrect right now, but we'll get through it as long as this helps you guys understand what the cladogram is, okay? So, where were we? Oh yeah, green nucleus. So, let's just say the green nucleus goes there. So at this point in time, anything above here is going to have a green nucleus, all right? And anything above at that time is going to have a black circle. I say time because this also represents time. So if you notice right here, recent, long ago. So the higher you go up, the more elevated you are, the most recent in time it has actually happened to, like us, like right now, like whatever, what is it, like whatever date it is when you watch this video. Let's just say that date, all right? So the most recent of this species are going to have those traits, because this one, the black circle one, was basically came about and existed before they decided, not really decide, but before the trait of that green nucleus came about. All right, so now let's figure out the last 2. So the 2 over here. Out of these 2, which homologous structure do they all share? Yep, I'm right and you're wrong, whoever said that, because you said it wrong, that one student. Yep. It's you. So it is the red hair. So let me get my red marker. Let's draw them. So we got the black circle. Let's just kill time by drawing the black circles, because my life has come to nothing now since we have no more school. I don't know how to live, but that's my problem, not yours. Okay, so yeah, it's actually the red hair. Good job, guys. So it is the red hair that, let's say at this point in time, because remember, the further you go up, the most recent in time it is, because that's time. So the more further you go up, at this point in time, they developed a red hair to make their own red-haired subspecies or just entirely new species, even though they all, right now, all three of them still share a common ancestor of that black dot. So process of elimination, the last one that we have is going to be the one with the blue ears. Or organelles, forgot, this is a single cell, so another organelle. Red organelle, that's green, I meant blue, which is over to the side. Come on, get yourself together. There we go. Boom, blue ears. All right, there you go. Cladogram, that's how you do it. So I'm gonna ask you guys questions, hopefully in a summative very soon, coming to a computer near you, about how a cladogram is gonna help you figure out, to figure out how they all share a common ancestor. So as we can see right now, right here, the black dot is a common ancestor right here. So if you go further down time, at this point in time, they shared a common ancestor, but it developed a black circle. So boom, that species went off to have a black circle. They kept on evolving, quote unquote, evolving, and then boom, that point in time, anything above this point is going to have a green circle, and then boom, only that black green circle species came about. Then at this time, anyone above here is going to have red hair. At this point in time, anyone's going to have red hair, but forgot to mark down the blue ears. So right here is, in time, is where the blue ears started to develop. This actually relates to like real things too. So for example, let's say if right here is going to be humans, that'll be chimps, orangutans, and then that would be gorillas. We, believe it or not, we are not monkeys. No, I'm not saying that, but we share a common ancestor with monkeys. So that common ancestor, whatever we all do share, it started to progress. So traits like opposable thumbs is what we got. If you compare ourselves to all those other animals, chimpanzees, orangutan, apes, we all have 2 eyes, a nose, ears. We do have fur, technically still. We call it hair, but this is actually fur. It's on our head now too. We share all those traits. But during some point in time, we got some traits from that common ancestor when it started to grow and develop, to split off into different species. We kept on evolving, and then that point in time, anything above there, so let's just say this is our cranial capacity and our ability to walk on our hind legs. Anything up that point, so like Neanderthal could be right here. Homo erectus is going to be like right there. So those are different species that we all share a common ancestor with, even with the chimps, orangutans, and gorillas. But at that point in time is when those traits started to develop, and then through genetics, since they kept on breeding, you inherit your genes. So if that trait already happened there, most of the population had it. Any point from that time, that trait's gonna get passed on, and then it finally develops into a new species like us humans compared to Neanderthal and Homo sapiens. So just to recap, our cladograms are here to help us figure out the relative closestness of relatives. So for example, if we had this one, and I'm asking you which one is the closest relative to, let's just name this Bobbert. So B for Bobbert, C for Clara, T for Timothy, and then P for Post Malone. All right. So for Bobbert, which is the closest relative? You better not say Post Malone, Timothy. You would better say, I forgot her name, but whatever C stands for in your mind, that's the closest relative. Because remember, time is up. The most recent in time to our point right here, the higher you are. So let's just say that that's going to be, let's just say 5 million years ago. This is going to be 7.5 million years ago. That's 66 million years ago. And then let's just say that's 800 million years ago. It's for time. So since this happened 5 million years ago, where this species came to existence, the closest relative to that species is going to be this species. Bobbert's going to have, for Catherine or whatever I call her again, I forget. So Bobbert's closest relative is Catherine. Even though they all do share a common ancestor, they are different species. And this cladogram is there to help us figure out the relative closest in relatives to our species. This is another tool or way that scientists use in order to assess common ancestry is through time. How far long ago did this certain trait develop in this species to arise into a new one? So same thing for the homework assignment you guys did the other day. We had those 3 fossils and we had that snake. So one of them had like gills, one of them had long webbed feet, one had little stubby toes. So those were those traits right here. As we further went along, we noticed that some of those traits got dropped and were replaced for new ones. So let's say if this was a snake, we know it's gonna be relatively close to the other ones because they all had that same similarity. The circle was the detached jaw. So this one had long still. So that one actually had long legs. So long legs came into play, and that one gave rise to the fox kit. And then, no, actually this was the fox kit because they had long legs and fur. And this one was for a fish. I forget what, but it's your homework assignment. You should figure it out. So as we progress through the traits, we know that they all like accumulate, come together to form a species. So we're going to see like remnants of the past in those separate subspecies because through time they developed those traits, and only at that point through time anything over there would have that same trait. So that's why you don't see blue ears on this one, because that trait never came into fruition for whatever reason. So that's why this one is without ears and all the other good stuff, because it didn't happen in his timeline. Further along you go, for that common ancestor to arise to these, it happened. So that's how we get those 4 different unique species. So that is it for today, guys. Hopefully you guys learned it well. If not, send me an email. You know, I'm always here for you guys. But that is it. You guys have a good one. Do your assignments and have fun in your other classes. Bye.